Good morning, everyone. Teacher Miriam here. This is my dog Sherlock. He's getting to spend every day with me while I'm creating lectures and creating content. You can see he's kind of bored, but he doesn't like it when he's not in the room with me. Anyway, I figured I'd start the video out slightly different today. So there you go. Today we're going to be talking about bar graphs. So as usual, I'm going to turn off my picture here in just a moment, and I'll start writing on my screen. All right. So I hope all of you are having a good day. I appreciate what all of you are doing, how hard you're working, handing in your assignments, and all of that kind of stuff. So let's get started. All right. So a bar graph is very similar to a pictograph. And you can see right here, this is a nice example of a bar graph, right in the center of the thing. And basically just a bar graph means a bar. It's much easier to draw than a pictograph because you don't have to draw as many things. But it's actually also a more useful graph. So pictographs are more of a thing for little kids. Once you get older, you don't make pictographs anymore. You make bar graphs, okay? So the first thing that you have to be aware of with the bar graph is that you have a pattern. And the pattern is really, really important, okay? Every graph has a pattern. It's not a collection of random numbers. And I'll show you an example of this. So this pattern right here is the times 5 pattern. So you can see 5, 10, 15, 20, 25, 30, 35, 40. This graph here, this is a times 2 pattern. 2, 4, 6, 8, 10, 12. And these ones down here, they don't actually have patterns because we don't need it. Because that's for a different thing, okay? So when you have a collection of data, let's say you have 7 of something and 5 of something and 11 and 10 of something, you do not make a bar graph and go 5, 7, 10, 11. That's completely wrong, okay? When you are doing this, you have to find a pattern. So in this case, I think 2s make sense. So I'm going to go 2, 4, 6, 8, and I'd left myself not enough room here, but 10, 12. You see how I have my pattern there? I must have a pattern. And you see how I went in order? I didn't just go 7, 5. Now you're going to be making bar graphs tomorrow, not today, but this is a really important concept that you have to have in your head. It's not just whatever number you want. This axis right here is a pattern. And I expect to see a pattern here, not just a random collection of numbers, okay? All right, so the next thing is the bar graphs always have 2 sections. They have what's considered a number section, and then they have a data section. And that's what this down here is looking for. So you can see, I'm gonna do it in 2 different colors. There's my number section, and there's my data section. And then here, data section at the bottom, number section on the side. And then we go down here and you can see the same thing. Quantity means number. Oops, sorry. So on this one, my quantity is at the bottom. On this one, my quantity is on the side here. Okay, there's always 2 sections. And it doesn't matter whether you make the bar graph this way or this way, you have a number section and a quantity section. Sorry, a number section and a data section, okay? I'm just going to erase all of this because it's going to mess me up later. All right. So that's another key thing that you need to know when you're doing a bar graph. All right. So make sure that you look at both, okay? The third thing I want you to note is that numbers on a graph mean something. You can figure out a lot of information based on it. So if we go again down to this graph right here, we go graphs, that's a 35. Whereas this one right here, if I draw it straight across, there's a 30. Looks like this graph is really nice to you. That one's exactly on 10. That one's exactly on 25. And this one is exactly on 40. And that's a really nice graph. They're being friendly to you. But what if this one was a bit taller? And it was like this instead. Okay? If that was the case, then now, when you draw that line across really straight, it's somewhere in the middle. So the question is, what is that number? It is not 25 and it is not 30. And I do expect you to use your simple math skills to figure out what number that is. It's not 39. 39 would be really close up here. And it's not 26 because 26 is down here. This line is either going to be a 27 or maybe a 28. And I would accept either one of those because that's hard to tell. All right, but please be precise on this. Okay, use your numbers. The fourth thing I want you to know about this is that this graph is just so full of information. There is so much going on in here, and you have to pay attention to what the question is asking you, or you won't get the right answer. Okay, this is really, really important. You cannot guess on graphs. You have to look at what the question wants, okay? And the last is the same point as yesterday. How many more is not an addition question? Okay, so let's do some examples here. How many children were asked? Oh my goodness, this is a problem. Because how in the world are you supposed to know that? Well, it's actually not that hard. This is 30, whoops, wrong pen. This is 35, and this is 30. This is 10, this one is 25, and this one is 40. So if I want to know how many children were asked, I have to add all of these numbers together. And that's everybody. 10, 1. I should have actually said people because your graph says people. Okay, it says people there, so it should say people. Sorry, excuse my cough. All right, so 3, 6, 7, 8, 10, 14. So 140 people were asked. See that? How I added everything together? Okay. Now, if the teacher wanted to make the most students happy, which two fruits should she bring? Well, we're going to look at the ones that are the most. She should bring blueberry and she should bring apples. And between the two of those, and if I asked how many students would be happy, then we could add those two together, and I would have 75 students are happy. Okay? So that's how you use a graph like this. And there's a lot of other things that you can figure out on this graph. You can have all sorts of different kinds of questions. Here's another one that I didn't write down, but it's actually really important, so I'm going to write it down now. If apples cost $2 each. That's a really expensive apple, by the way. Don't buy $2 each apples. Cost. How much would it cost to buy apples for everyone who likes apples? Okay, not for the whole class, but for just the people who like apples. And I'm actually not going to do $2 because that's a ridiculous price. So we're going to say 49 cents. Okay. If apples cost 49 cents each. Okay. Well, now we do think it through. There are 35 people who like apples. And one apple is 49 cents with a decimal in there. So we have to multiply those two numbers together to know how much it is for each of them. So this is 45. That's 27. 31. Then remember we put the 0 there. You guys know how to do this math. So remember how to do it. 12, 14. We add those together. 5, 1, 7, 1. And remember we've got two decimals. So it would cost $17 to buy apples for everyone who likes apples. Okay? That's how those kinds of questions work. So we take the number from the number of people, which is 35 people, and we take the cost of the apple and we multiply them together. And that will tell us how much it cost to get apples for those people. All right, I'm going to skip this middle section here for just a moment, and I'm going to go down to the bottom. And I'm just going to show you that these two graphs are exactly the same. And I'm going to highlight each section. Okay, so items are here versus items are here. Okay, so here's your A, B, C, D, E. And here's your A, B, C, D, E right there. Okay, They are the same thing. They're just on a different side. Then you go to the bottom, you have quantity on the bottom on this side, you have quantity on the side on that side, but it's still the same thing, okay? And so that's why it uses these two terms. This is a horizontal graph. The lines are in a horizontal direction, see? And this is a vertical graph. The lines are in a vertical direction, as you can see. Both of these graphs are missing something. They don't have a title. Titles are very important. Can't leave them off the graph. They tell us what to do, all right? So you can do graphs either direction. So don't think you're stuck in one direction or the other direction. It's just that this section here always has to line up with the number. So it has to point to a number. When you draw a line straight down, it should be pointing at a quantity, an amount, a number. And you can see these ones are doing the same thing. They're pointing to a quantity or an amount. So remember what I said, when you make these graphs, you make them with a number pattern. So for example, you could go 10, 20, 30, 40, 50, 60, 70, 80, 90. See, there's a number pattern there. This one maybe has a different number pattern. Maybe this counts by fours. 4, 8, 12, 16, 20, 24, 28. Okay? So what the number pattern isn't actually as important as that you keep a number pattern. And this is always 0 in the corner. All right? Now, grade 5s, you probably should listen to this part, though you don't have any work that's directly related to it, but I'm going to address some things that might help you in your work. But if you decide, like you seem to frequently do, that you don't want to finish watching the whole video, then I guess this is the time for grade 5s where you can check on out. You're doing day 80 in your workbook. All right, grade 6s, please keep on watching. This is important for you. So this now is what's called a double bar graph. Double bar graph. And it has two pieces of information, or two sets of data in it. Now, this is the best kind of graph because it shows you so much information all at once. The reason we learn how about these kinds of graphs up here is because we want to be able to do these kinds of graphs right here. And we use these primarily to compare things, to see either Mrs. Smith as opposed to Mrs. Williams, or Mrs. Smith as opposite herself, one on one day and one on the other. So we're going to go over some questions so you can see how that works. Okay, so which teacher gives about the same amount of homework on both days? Well, we can look at this. Well, it's obviously not Mrs. Brown. That's very different. So Miss Smith, she gives about the same amount of homework on both days. These two lines are very similar, right here versus right here, whereas everything else. Which teacher has a huge difference in the amount of homework assigned? Well, that's Mrs. Brown. You can see on Wednesday, the pink, she doesn't give very much homework at all, only 6 minutes of homework, whereas on Thursday, she gives 18 minutes of homework. So there's a big difference between the two. All right, so now, which teacher gave the most homework? Okay, now see, this is an interesting question because it specifically says over the 2 days. That means that maybe it's Mrs. Jones, but maybe it's not. Mrs. Jones gave the most homework on one single day, that's true. But in order to know whether she gave the most homework on the 2 days combined, we have to see how much homework each teacher is given. So Mrs. Smith gave 14 minutes plus 16 minutes, which equals 30 minutes of homework. And Mrs. Jones gave 16 minutes plus 20 minutes of homework, which equals 36 minutes. So it is Mrs. Jones, but not because she has the tallest one section, because when you add her two sections together, she has the biggest number, okay? And then how much homework did Mrs. Jones give in all? She gave 36 minutes in all. I don't want to hear that she gave 16 minutes on Wednesday and 20 minutes on Tuesday because this question is asking in all. And in all means you have to add it together, okay? And now, which teacher gave the least amount of homework on Wednesday? See how I keep switching around about what I'm talking about? So now I'm talking about Wednesday, which means I don't care about Thursday at all. What happened? I don't care about Thursday at all. I'm not going to look at Thursday. It's not important because this question is about Wednesday. The previous question, so you have to pay attention to what each question is asking about. So which teacher gave the least amount of homework on Wednesday? That would be Mrs. Brown. Because on Wednesday, she has the smallest. If you look at all the pink ones. Now, the next question says on Thursday. So it's flips now. Now I don't care about Wednesday at all. I'm not going to look at Wednesday. And I'm going to look only at Thursday. And on Thursday, it's Mrs. Williams. Okay? Because now when we look at Thursday only, we can see that this one is the smallest because we're only looking at the purple ones. When you're doing this work, make sure you're answering the question being asked. And that's the great strength of graphs. It's also what makes kids so frustrated about graphs, is because you have to be really thoughtful about how you answer questions. And the last question I'm going to ask you is, if it takes Fred 3 times as long to do homework as everyone else, how long did it take him to do Mrs. Williams' homework? All right, now this is a multi-part question, and I'm just going to write it up here. So the first thing is we have to know how much homework Mrs. Williams assigned. So we have to go 14 and we have to go 10, and we have to add them together. So Mrs. Williams assigned 24 minutes of homework. Okay, that's what she gave, was 24 minutes of homework. But Fred takes 3 times as long, which means we have to go 24 times 3. And we do that math, and we get 72. So it actually takes Fred 72 minutes to do Mrs. Williams' homework, which is a lot more time than anyone else, right? Pay attention to these kinds of questions. You get them a lot in your work. Okay, so that is the end of this lecture for me today. I hope that makes sense for you. Remember, you can call, ask any questions you have. Make sure that you don't forget to make the phone calls with any questions, and make sure you don't forget to hand in your homework. So grade 6s, you're doing day 81. Thank you, and have a great day.